No.
Alrighty. Let's solve for x. What does that say? Oh, so my handwriting didn't even improve over the breaks. Okay, how do we start to solve this one? Solving for x. I want to find x equals blah, blah, blah. Anyone can feel free and just start writing on the whiteboard, I believe, I hope. Just try it out, write some scribbles and see. However takes over can take over. No. I do want to get all my X's on one side, all my number business on the other side. So
How do you whiteboard?
Well, okay, like, I don't know if it looks the same for you. I hope so. On the left side, it has like an arrow, a pencil thing.
On your screen? It should look on your screen.
It should say that on yours. Go down to whiteboard on the bottom right. Does it say that on yours?
No.
No?
No.
Can you see my screen? See my screen?
Yeah, I can see your screen, yeah.
Let me see. I have all allow participants to access after the meeting. Yes, I have it there. How do you start to use whiteboard? What does it say on the bottom of your screen? It says like participants, chat, stuff like that.
Oh, yes, as participants, yes. But how do I go to the whiteboard though?
All the way to the right, it should say apps and maybe whiteboards all the way to the right on the bottom.
No, I see record reactions. And then there's a leave button. Can I just tell you what to do?
Yes, sure, that'll work too. Go ahead.
You subtract 3 from 3 and then subtract 3 from 23.
Subtract 3, yes. And where did it go?
I don't know.
Love this thing, I love this thing. I'll write it again, not a problem. So you say, hold on. To -3 and -3. So it leaves me with -5/3. So sorry. X equals 20. Now what?
I kind of get confused here with I don't like the fractions, but do you like do 3/5? Is that what you do? So like kind of like,
Yeah, I can do that. Basically, I'll make this into a fraction looking thing. So 20/1, and I want to divide away this because I want to get rid of it next to the X. So I'm going to divide -5/3 and divide this whole thing by -5/3. And when you divide by a fraction, you really flip it and multiply. So this does like a karate thing and comes up here. And he's now multiplied by 3 over minus 5. So I have x equals 20 over 1 times 3 over minus 5. And then what?
Do you find like common denominators? Is that what you do, or?
You can do that. You can do how many times, like a crossways to see if they're
Yeah,
a factor.
20.
Yeah. How many times is 5?
Okay.
So 5 into 20, 4. And then 4 times 3, 12 over 1 times, this is just a 1. But I have my minus still here. So this whole thing is minus 12. So x equals minus 12. I got to try to bring fractions in a little bit, a little bit at a time, because or else you'll never be able to practice them. Let's see another one. Okay, so 5 equals 7 minus 2 times 3x minus 1 plus 6x. I want to solve for x. Still, I want to combine my stuff and have x equals blah, blah, blah.
Don't you go 2 times, or when the times the parentheses, so it'd be 2 times 3x, then 2 times 1.
Okay, 2 times 3x. So I'm going to rewrite the whole thing and just handle those items. So minus 2 times 3x is minus 6x. And minus 2 times minus 1 is plus 1. And then I have my 6x. What's the next step?
Combine like terms, so 7 plus 1.
7 plus 1, okay, 7 plus 1 is 8, so 5 equals 8 minus 6x and plus 6x.
Then you subtract 8 from both sides.
It's 8 minus 8. And minus 3 equals minus 6x. It's 6x.
Then I guess you add the x's together.
So minus 6x plus 6x gives me nothing. 0. I end up with minus 3 equals 0, which means this equation doesn't really work. It doesn't, I cannot have that. I'm left with no x's, so I would put inconsistent. I'm not going to try to type something. Inconsistent or no solution. This. Okay. So let's bring in a little bit of English into it. Once in our lifetime, I will do this. What kind of words are these? Don't say English. What kind of words are these? You can see them, yeah?
Are they nouns?
Oh, I don't know.
This is English.
Yeah, it's English. I don't know my parts of speech like that.
Two-syllable words?
Yes, okay, but there's a special kind of grown-up way to describe those. Where one of the syllables is a word on its own, and the other one is a word on its own, and then you can put it together. Oh, this is a tricky question, huh?
Would it be like a conjunction or something like that?
I'm gonna take
Can't
it's a,
remember.
it's a compound word,
Compound. That's what I was looking for.
right? So rain is a word on its own, and storm is a word on its own. Sun is a word on its own, set's a word on its own. Flag and pole, sail and boat, and tea and cup. The jury is still out. I think like this should be a compound word. And I have asked many English professors and they're like, I don't know. But this is a word by itself, sum, the sum of two numbers, and then Mary's a word by itself. So summary should be a compound word. But it's not. Okay, so we have compound words and we also have compound inequalities, which is, let me check. Where it's kind of two inequalities shoved together to make one long ridiculous inequality. But it's called compound because you have to solve them separately. You have to solve the left side, you have to solve the right side, and then you have to bring them back together for the answer. So this is 3. 3 is less than or equal to x. And x is also less than or equal to 7. So you could also say that x is between 3 and 7. And if you had a number line, and we had 3, 4, 5, 6, 7. If I was doing it with the dots, are my circles open or closed?
Wouldn't they be closed?
Closed, right? When I color them in or fill them in, that means it includes that number as the answer. And then I can connect them. Because now that shows me that 3, all of my values, 3 plus everyone above 3, up until and including 7 will work in the equation. Okay. So I'm gonna just add more stuff and more stuff. Okay. 2 is less than or equal to x plus 3, less than 12. So I'm gonna solve this side first and pretend like the 12 isn't even there. Right, I'll work on the 2 less than or equal x plus 3. I'll move the 3 to the other side. Right, so I have this part is solved. -1 is less than or equal to x, or x is greater than or equal to -1. And then I'll solve the other side. X plus 3 less than 12. I'll take the 3 to the other side, so -3, -3. X is less than 9. And now I'm gonna smush them together. I'm gonna write -1 less than equal x. And here's my x, I kind of less than 9. And if I had to show it on the number line, I go from -1 to okay, my 9 is my 9 open or closed? The dot above the 9 open or closed? Open.
Open.
Yes, open because it does not include 9 as a solution. It gets really close to 9, 8.99, but it's not exactly 9. So I'll leave that open. And the -1 on the -1 part, that's going to be colored in, filled in, because it includes -1 as an answer because it's less than or equal to -1. If I were using the hard brackets, this one would be a hard bracket up until an open bracket. Questions so far? You just have to remember to do one, do the other one, and then kind of smush them together. So x plus 2 less than 5 or x plus 3 is greater than 8. So this one, I'll take the 2 to the other side. So I have x is less than 3 or, and here I have, I'll take my 3 to the other side. We have x is greater than 5. And you see how the symbols are facing opposite each other. That's why it has the or in there, because I can't be less than 3 and be greater than 5 at the same time. I have to choose one. So that's why I write it with the or instead of together. So this is, I guess it's still a compound, but because it's 2 of them together, but this is how you have to write the answer. X less than 3 or X is greater than 5. I would graph that one. X is less than 3. Open or close circle. Thing. Be open. And I'm getting everyone less than 3. Does not include 3. Or X is greater than 5. Open or close on the 5. Open, close, close. No, it shouldn't be closed because it's,
Be open.
yeah, open. Because it's, does not include 5. Okay. That's why you can't write them together, because they can't be both things. I can't be, you know, under 6 feet tall and over 6 feet tall at the same time.
So it's only closed if it's equal to?
Yes, if it has the little symbol underneath it that shows that it's equal to, then it's going to be colored in. And then if you use the brackets, this would be an open bracket, like a soft parentheses kind of thing to the left, or an open parentheses to the right.
What did you say again about the, like, why we put the hard brackets and why we put the soft brackets? Because I thought I understood it, but then I started doing the assignments and I was getting it wrong.
The hard brackets is like coloring in the circle. So the hard bracket
Oh,
is the same thing as coloring in the circle. It includes that number, or it's less than or equal or greater than or equal. This doesn't actually see equal sign. And the soft bracket is like, it does not include, it's like the open circle. It doesn't include that number. It goes all the way up there, but it's not bam, hard and including that number. It's, I'm getting really close, but I'm really not touching you. It's like, you know, that game where you poke and you're like, oh, don't touch me, don't touch me. I kind of got close, but I didn't really touch you. It's like that. This is the same thing as that one, or less than or greater than without the equal sign on the bottom. That probably didn't make any sense, right? Like I'm so close, but I'm not, I don't include that number. I can get all the decimals up until that number, but I don't include that number. And the hard bracket is the one that is this, it exactly includes that number and everything to the left or the right of it. Or you can send me the screenshots of the problems that you have. And I can see what happens, but I don't know what WebAssign likes to do, put it that way. Minus 2x So 5 is less than minus 2x plus 3, less than or equal to 13. Compound inequality. Oops. Because I have two inequality symbols. So I have more than one. It's compound inequality because I have two symbols. Okay. So I want to work on one of them first. So I'll work on the 5 is less than minus 2x plus 3 and forgetting about the 13. So what do you want to do? You want to take away the 2x to the other side or bring the 3 on that side?
Wouldn't you do the 3 first?
I'll take the 3. Minus 3, minus 3. Leaves me with 2 is less than negative 2x. I want to get x by itself. So I'm going to have to divide away the negative 2. So here I'm going to have minus 1 and x. But anytime I divide or multiply by a negative number, I have to switch the sign. So this is less than, I'm going to make it greater than. Now I work on the other side, the minus 2x plus 3 less than 13. Less than equal to 13. Same thing, I'm going to move away the 3 to the other side. Leaves me with minus 2x less than or equal to 10. I'll divide away the minus 2. Leaves me with x and minus 5. Because I divided by a negative number, I'm going to switch my inequality symbol. So instead of less than or equal, it's going to look like that, greater than or equal. So now I can put these together. All right, my new answer, minus 1, minus 1 greater than x greater than or equal minus 5. On the number line, so I have minus 1, x is going to be smaller than that. So my dots are going to be over minus 1 and minus 5. Okay. If you want, you can switch it and write it the other way, if that's easier for you. Let me do this way and you'll see. And you can decide what's better for you. So -1 is going to be bigger than my x. So x is going to be smaller than -1. It's going to be all over here someplace. And -5, x is going to be bigger than that. The -5, it's on the left because it's negative, even though it's on the right here. It's going to be colored in because x is greater than or equal to it. And it includes the -5 as an answer. -1 does not include it, so I leave it open. I could also do a hard bracket to show that it includes this -5, to a soft bracket because it does not include -1. And it may look weird because the 5 is over here, but it's really over here. You can just write it this way. -5. -5, you want the pointy part to still be by the -5. X. You want the pointy part to be by the X. And now it looks more like the graph. And all I did was just kind of, mirror it on itself. Either way, it says the same thing, so either answer will be correct. Questions about that? No?
No.
Okay. Meet with us. 8. Okay. 8 is less than or equal to 3 times x minus 1 plus 2 less than 14. We'll do one side. So all the way up until the second inequality symbol is 1 like side. So 8 is less than or equal 3 times x minus 1 plus 2. What do I do first? Okay, good job, yes. I will take this 3 times x and 3 times minus 1. So x is less than or equal to 3x minus 3 plus 2. And then I'm going to combine my like terms. Put the numbers with the numbers. So x is less than or equal 3x. Minus 3 plus 2 is minus 1. And now I'll take my 1 to the left side. Plus 1. Nine is less than or equal 3x. I divide both sides by 3. And I have X greater than or equal to 3. And if you want to switch it at this point, you can do that. Either way, I'm going to write them both ways. X, and I want the large part to be by the X is greater than or equal to 3. These are both correct. They both say the same thing. And then I'm going to take my 3 times X minus 1 plus 2 less than 14 and solve for that one. Less than 14. So I'm doing 3 times X, 3 times minus 1 again. So 3X minus 3 plus 2 less than 14. Combining my minus 3 and plus 2. So I have 3X minus 1, which I could just take from here. Like if you write neater than I do, then you know that that whole middle part shrinks down to 3X minus 1. So 3X minus 1 less than 14. I'll move the minus 1 to the other side. So plus 1. Leaves me with 3X less than 15. I'll divide both sides by 3. And X is less than 3. So since I have this one, it's already like this, I'm gonna go with this way that the answer was written. So 3 is less than or equal to X less than 3.
Miss,
Yes, I think I messed
15
up.
divided by 3 is
It's
5.
fine, thank you. I'm like, why does it look like that? Okay. Thank you for looking out for me. It's like, that doesn't make any sense. Okay. So 3 less than or equal to X less than 5. And now with my line, so all of my good stuff happens between 3 and 5. I try to write one or two numbers past where the action's happening. So my graph doesn't look so weird. So on 3, do I have an open or a closed circle on 3?
Closed.
Closed because it includes 3. It's 3 is less than or equal to 3. X star. And 5 is open or closed.
Open.
Open because X is less than 5, but does not include 5. Now, if I use the brackets, would I have a hard bracket or a soft bracket over the 3?
A hard.
Hard bracket because it includes 3. And a hard bracket or a soft bracket over the 5.
A soft.
Soft. Okay. We're almost speaking math. Now, what's the worst thing that could happen with these inequalities? Fractions, yes, fractions. Also, you can graph them on the plane, like how we used to graph like this. Not used to, not like it was so long ago. We can graph lines with the same like condition of inequality, like it's not a solid line that we'll be graphing. Because it's not equal to all those things, but it may, X may be less than or equal to something, or Y is less than or equal to something, or my whole line is less than or equal to a number, and it would be graphed differently. It would be, if it's equal, then it's gonna be a solid line on the graph. Like if this is my Y and my X. And maybe if it's not equal, it's gonna be a dotted line to show that it's not including that value, but maybe less than that or greater than that. And then we'd pick a test point. That's how I do it. I pick a test point because just because it says less than doesn't mean it's on this side. So we get there now. So we're gonna graph lines with inequalities and see what happens. It's not the worst thing. Okay. So we're graphing X plus Y less than 3. So I'm gonna do my table of values. Remember that? I'm gonna do my table of values. I'm gonna try to write a little neater. And I'm gonna pick X is 0 and see what I get for Y. So if X is 0, what do I get for Y? I get Y less than 3. And I don't want to write the Y less than 3 here. So I'm just going to write a 3. I'm going to pretend that it's an equal and it's kind of a normal line. And then I'm going to think about this less than thing when I get to the graph. Okay, so if X is 0, Y is 3. What if Y is 0? If Y is 0, and I have X is 3. So I have 2 points. Go ahead. You had a question? Okay, now I have 2 points that I can put on the line, right? 0, 3, and 3, 0. Okay, so 0, 3 is I don't move any left or right, and I go up 3. And then 3, 0 is I go to the right 3, and I don't move any up or down. And I want to connect it, but I don't want to put a solid line because it's not equal to 3, it's less than 3. So I'm going to put a dash line, or it's going to be so crooked. A dotted line. And then I want to see which side to shade. So I'm going to pick, I try to pick the cheapest, easiest one for me to do. which is the origin point, right? If I pick 0, 0, oh, what is that? If I pick 0, 0, I would put 0, 0 into the equation, the inequality, and see if it works. 0 plus 0, so that's my point that I chose, 0, 0, less than 3. 0 plus 0 is 0. And is 0 less than 3?
Yes.
0 is less than 3, so I'm gonna make sure to shade the part that makes it true. I'm gonna make sure to shade this side, but nicer, like in the colored kind of so nicer. I'm gonna shade this side to show that this line, x plus y, is less than 3. It's almost to 3, but not exactly 3. So it's not a solid line. It's everything under that. Okay, this is the part of class where you need colored pencils, because if we're shading 2 or 3 lines on one graph, we need to see where the overlap is. Okay, so questions so far?
No.
Do you guys need a break? No? No break needed?
Yeah.
Break, I thought so, okay. Okay, break for 5 minutes. You pause, all right. Okay, we're back. Okay. Let's try this one, inequalities. Let's try to graph these two as a solution. X less than or equal to -2. Y less than 2. Graph them as lines, okay? I'll make the X on this graph this color, and then the Y one. Okay. So we have, if X is less than or equal to -2, then it's a solid line because it's or equal to -2. So my X value is this. I'm gonna pick another pointer. I always try to pick, as long as the line doesn't go through the origin, I will pick 0, 0 every time to try to see if it works in the equation. So if my point is 0, 0, and X is less than or equal to -2, I have 0 less than or equal to -2, and 0 less than or equal to -2. Is that a true thing? Is 0 less than or equal to -2? My zero's over here. It's not less than -2 because it'd be over here someplace. So since this doesn't work, I'm not gonna shade where the origin was. I'm gonna shade over here. Like nicely. Try to shade better than I shade. I'm not a great artist. Okay, so I'm shading the other side. And now I'm gonna do the y is less than 2 equation. If y is less than 2, then my y line is gonna be on. It's gonna be on 2. It's gonna be a dotted line because it doesn't include -2. It's gonna be like this. And I still want to choose a point to try. I know I want to do it less than 2, which will be on below the line, this thing. But I'm going to choose 0, 0 to see. If it's 0, 0, then 0 is less than 2. And is that true? Is 0 less than 2? Yes, 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 0 is less than 2. So 0 is less than 2. I'm going to shade the part that's going to hit the 0. And I'm going to try to shade neither. I'm going to shade everything that's less than this line, but not on the line. So now I can see where my solution part is. The part that the red and the blue overlap is going to be my solution part. That's going to be everything from here, where y is less than 2 and x is less than or equal to -2. It's all of this stuff, the stuff that they have in common. Oh, finally, good shading. No, it's ugly, but does it make a little bit of sense? No, I just realized that my camera wasn't on. Jeez. Okay. Okay. So I'm going to do another one with 2 graphs. X plus Y equals less than or equal to 3, and Y greater than equal to 1. Let's say I want to graph both of these at the same time. Okay. So the one with the X and the Y in the equation, I'm going to do the table of values. I'm gonna choose if X is 0, what do I get for Y? And if Y is 0, what do I get for X? That gives me 2 points that I can start graphing the line. So if X is 0, I have 0 plus Y less than or equal to 3. And I have Y less than or equal to 3. And I'm gonna pretend that it's an equal sign until I get to the actual graph. Y equals 3. And then if Y is 0, I have X plus Y equals 3. And I have X is 3. So I have now 2 points, 0, 3. And 3, 0. And I only need 2 points to plot the line. So I have 1, 2, 3. So 0, 3, I don't move anywhere. I go up to 3, and 3, 0. Go over to 3, and I don't move anywhere. Is this line gonna be a solid line or a dotted line?
A solid?
Solid
No, I
line,
got it. No, solid. I was right.
yeah. Solid because it includes the 3. It's less than or equal to, so it's gonna be a solid line. Why is it red? And then I'm gonna choose my test point. Since it doesn't go through the origin, I'm gonna choose the origin and check the points. So I'm gonna check 0, 0. If 0, 0 works in the equation, then I'm gonna make sure to shade the side that hits the 0, 0. So 0 plus 0, is it less than or equal to 3? Zero is less than or equal to 3. So I'm gonna make sure to shade the side that has this 0, 0 in it. Let me show you this time. This time should be good. I'm gonna make sure to get all of this that is less than or equal. Then I'm gonna do my other equation. Y is greater than or equal to 1. Since I don't have an X, I just have like a flat line. It's what X can be whatever it wants to be as long as the Y is greater than or equal to 1. Is this line gonna be solid or dotted? I'm gonna be here someplace. Solid line or dotted line through this Y?
Solid.
Solid, right? Solid line. And then I'm gonna check my origin point. Since the origin is not on the line, I'm gonna check 0, 0. I'm gonna see if 0, 0 works. I'm gonna make sure to shade the side that hits the 0, 0. If not, I'm gonna shade the other side. So if Y was 0, I would have 0 greater than equal to 1. Is 0 greater than or equal to 1? No, miss, it's not. Good job, guys. So 0 is not larger than 1, so I'm not gonna shade the side that has the 0, 0 point in it. I'm gonna shade the other side. And then you can see where your overlap is. Your overlap for if these were two equations that happen here to here. It'll be only the things that y is greater than 1 and x is less than 2, looks like 2-ish, maybe. But this will be overlap here, this little piece of 5. See? Okay. I'm putting like easy things to graph because I'm not trying to trick you on the graph part. Not that I'm trying to trick you anywhere, but I want to make sure that you understand the concept instead of, you know, trying to graph 11 over 14. Like that's not the goal. So let's say we graph the solution to x is greater than equal to 0. And y is greater than equal to 0. And because I can put as many graphs as I want to, and then the lines and x plus y greater than 4. Okay, so I'm going to have 3. I'm going to have 3 lines on one graph. Okay. So I'm going to do x is greater than 0. Do x will be in this pinkish red color. So x is greater than 0 means I can have whatever I want for y. It can be anywhere up and down here as long as x is greater than or equal to 0. So this line here is solid because it includes 0. Pretend that this is right on the line, okay? And I want everything to the right of it. So I want to color all of this to the right. Everything that shows that x is bigger than 0. I don't care what y is. Oh, it looks like a flagpole. I'm trying to shade really neatly. Okay, everything to the right of 0. Y. And y greater than equal to 0, which means my y, I want everything up here. I don't care what x is. It's kind of weird that when you're talking about the y, you have to write on the x line, but that shows you that everything up here is bigger than 0 for y. and then x plus y greater than or equal to 4. When I have an x and a y in my equation, I'm gonna do the table of values. And I always pick if x is 0 and then y is 0, see what I get for the other value. Because I'm really just trying to get on the graph and see what I have. So if x is 0 and the x plus y greater than 4, I have 0 plus y greater than 4. So y is greater than 4. And I pretend it's an equal until I get to the graph. And if I have y is 0, then I have x plus 0 greater than 4. So I have x greater than 4 or equal 4. So now I have 2 points that I can put on the graph, 0, 4 and 4, 0. I put those 2 points on the graph. Zero, 4 and 4, 0. What kind of line is going to connect them? Is it going to be a solid line or a dotted line?
A dotted.
Dotted line because it does not include the value of 4. It's just greater than it. So I'm going to put a dotted line. And I'm going to check the point 0, 0 to see if it works in the equation. If it works and the statement is true, I'm going to shade the part that includes that 0, 0. If it doesn't, I'm going to shade the other side. So I'm going to check 0, 0 in this equation. So 0 plus 0 is greater than 4. Is 0 greater than 4?
No.
No. So I'm not going to shade the side that includes the 0, 0, my test point. I'm not going to shade this side of this dotted line. I'm going to shade the other side. So, oh my goodness. You guys could tell I didn't go to kindergarten now. I didn't learn anything. And now we want to kind of outline the part or the segment of the graph that includes all 3 colors, which is going to be, it's not going to be this little part here because there's no green in it. So it's going to go from here, here, to here. Get all this stuff. Oh. Okay, so that's all. It's not the worst. Not the worst. Yeah. Like a little tiny fraction, tiny fraction. 5/8 plus 4 equals 14. Oh my goodness. Stop. Oh, right like garbage. Equals 14. Okay, you want to solve for x. Solve for x. So 5/8 x plus 4 equals 14. And I'm just going back and forth because that's how the test is. And that's how problems on the homework are. So this one is an equal sign, normal kind of solve for x business. I move the 4 to the other side with the 14, so -4, -4. And I only put fractions in there so we can get practice with them because I don't want you to get to the test and know how to do everything, but not know how to use fractions. And then not do well, because I'm not trying to trick you. So I want to divide by the 5/8, right? So I'm going to divide this 5/8 away. And divide this 5/8 away. So I really have 10, and I put 10 over 1 because he wants to look like a fraction too. And when I divide fractions, I'm really flipping and multiplying. So this jumps up here and becomes 8/5 with a multiply. So I'm multiplying 8/5. I can go 10 times 8, 80. 1 times 5. 5. My 80 times tables. 16. 16. So x equals 16. Could I have done it another way? Yes. I can say 5 will go into 10 twice. So 5 into 1 goes 1 time. 5 into 10 goes twice. And what's 2 times 8? It's still 16. But that's easy. Okay, either way, you get the same answer. And I get x equals 16. And then box it and move on with more. Any questions? No?
Can we do another one like this?
I like the fractions. It's okay to like fractions. I think that's what's happening. Okay. Okay, so 40. Just 40. 40 minus x over 6 equals x over 2. I'm gonna put I'm gonna do this. I'm gonna make him look like a fraction also, 40/1. Okay, now if we can get rid of the fractions altogether, we multiply by a number that 1 can go into, 6 can go into, and 2 can go into. What number is that?
Can't you just do 6?
Right, I multiply every term in here by 6. So 6 times 40, 240. Minus, this is gonna be 6. And leave me with just an x. This 1, and leave me with 3. So 3 times x, 3x. And now I'll move my x to the other side, plus x, plus x. Gives me 240 equals 4x. You divide both sides by 4. So I get x equals 60. Okay. I'm gonna do another one that has a fraction that we're gonna have to divide away. Two thirds x minus 12. Okay. 2/3 x minus 12 equals 24. I want to move the 12 over to the other side because I want to have the x by itself. So plus 12 plus 12. I'm left with 2/3 x equals 36. And I want to divide away the 2/3. So I'm going to put 36 over 1. So he looks like a fraction too. I'm going to divide by 2/3 both sides. And when I divide by a fraction, I'm really flipping and multiplying. So I have 36 over 1 times 3 over 2. Equals 36 times 3, 108. Two times 1. So x equals 108 divided by 2, 54. X equals 54. X over 3 plus x over 8 equals 11 over 24. I'm gonna do this one differently so you can see that there's a lot of ways to do the fractions. 24, does 8 go into 24 nicely? Yes.
Yeah.
And 3 goes into 24 nicely also. Yes, 6. Yes, so I'm gonna make like a new denominator for all of them with 24. The 11 doesn't have to change because he already has a 24 in the bottom. But this one, whatever I do to the bottom, I'm gonna do to the top so that no one, feels a little way. So 3 times 8 gives me 24. So I'm gonna do 3 times 8. Oh my goodness. And x times 8. which gives me 8x. Then I'm gonna do 8 times 3 to give me 24. And so x times 3 gives me 3x. And now that they have the same number on the bottom, I can add them. 8x. I kind of have this 8x plus 3x. They have the same denominator, so I can do this. Equals 11 over 24. So I have 8x plus 3x, 11x over 24 equals 11 over 24. This is the same number. So what do I have to multiply 11 by to get 11 again?
1.
1. So my x equals 1. 11 times 1 gives me my 11. And that's going to give me 11 on this side. 11 on this side. So x equals 1. And you can also do it that way. Instead of multiplying the whole thing by 24, I just made a new denominator for each of them. But you can also multiply the whole thing by 24 to get rid of the fraction. And you will get the same answer. Okay, 3 into 24 is 8. So 8 times x, 8x. 8 into 24 equals 3 times. 3 times x is 3x. 24 and 24, they cancel each other. And I'm left with 1 times 11. 8x plus 3x, 11x equals 11. I divide both sides by 11. Get x equals 1. Do one more like this. And then I'll stop torturing you. Two-thirds x minus x equals x over 9 minus 7 over 3. Do you want to give them all a new denominator? Or do you want to multiply the whole thing by a number that'll get rid of the fractions? You did make a choice. I don't want to choose for you. About it? Okay.
Would you get rid, like find a common denominator?
Yes, I'm gonna find something that works for the 3, works for the 9, and works for the same 3. What number can I multiply them? What number works for all of 3s? Can they all go into? 3. Well, 3 works for these, but it doesn't work for 9. It has to be bigger than the biggest number, either equal or bigger than the
It would
biggest
be
number,
9.
9. Okay, so I'm gonna multiply the whole thing by 9 over 1. Okay, so this first one I have 9 times 2 over 1 times 3 x minus 9x equals 9 times x over 1 times 9 minus 9 times 7 over 1 times 3. So I have 18 over 3x minus 9x equals 9x over 9, just x, minus 63 over 3. 63 over 3, 21. So 3 into 18 is 6x minus 9x equals x minus 21. I'm going to combine this side. 6x minus 9x is minus 3x. Equals x minus 21. I put a minus x to the left side. Minus 4x equals minus 21. Minus 4x equals minus 21. I'll divide by -4, both sides. I get x equals 21 over 4. Because there's nothing in common between 4 and 21. This is, kind of break these down. This is 3 times 7. And this is 2 times 2. Nothing in common. So this is my answer already in simplified form. I can't do any better than this. I can try to write it neater. I'm not going to change the numbers. It doesn't even look neater. Okay, I'll stay back if you guys have questions. I posted the homework on WebAssign. Oh, next week, I will not be here, but Monday I will post a video for you of the problem to take care of. And Wednesday, Dr. Torres is going to cover the class. Okay, I'm giving him all my notes. He knows I have a training at my other job next week, so I won't be here. So Monday I'll probably send you Saturday, Sunday, Monday, like 3 little videos of notes for Monday. And then Wednesday, Dr. Torres will be in class. You guys be your same, like, participatory, awesome selves. Like, don't give him more attention than you give me, because I'm going to feel a little way when I come in. So just like how you guys don't say anything in class, do the same for him. Okay. Yeah, guys, have any questions? I'm here. You can still text me though, but I'll have my phone. Okay,
Okay, thank you.
Have a great afternoon.
you too. Bye.
Bye, miss.
We just watched the video Monday, but then we come to class Wednesday.
Yes.
Okay.
Okay.
What is the class code for Remind?
Class code for mine. I don't know. Let me see. Who is that's not Olivia? Oh, you're not in there? Let me see. Let's see. You send a text to 811181010. Let me write it to you. So 8. Okay, you're gonna send a text to that, like that's the number that you're texting, and the code is at 724 888. So you put that part in, that code in the message part at 724 888.
Okay, thank you so much.
You're welcome. Okay.